Okay, let's go on to our lab number 10. This has to do with acid-base titration and the effects of concentration. As they say structure on pH, it actually should be as well be the effect of the type of weak or strong acid that you have involved. So there will be data for one such titration each. And the first part of this really is sort of a background information on the that we covered last week when we talked about acids and bases and different solutions, and the definition of Arrhenius theory for how the hydroxide and the hydrogen ions were used for that type of definition, and then how we went on to the Bronsted-Lowry theory where it looked strictly on the basis of the hydrogen ions being released or hydrogen ions being picked up. But those two both essentially work on the basis of hydrogen ions and hydroxide ions. And then this is a key point right here. A common and incorrect assumption often made when acid bases are referred to is that's in terms of concentration, and that's not the case. Strong acids and bases can be very concentrated or very dilute. It depends upon how much dissociation there is between that the conjugate base or the conjugate acid and the hydrogen ion released, or the conjugate base and the OH group that is released when it goes into a solution. Okay? So the degree of ionization determines whether it's a strong or a weak one, not the concentration. Now, continuing on, pH is minus the log of the hydrogen ion concentration. That's the key factor right there. And the next thing has to do with the way it's represented, with the acidity constant, or K sub A, is again, reactants are always in the denominator, the products are always in the numerator. So the concentration of the numerators are up here, concentration of the reactants are down here. So the pKa is going to be this right here, the hydrogen ion concentration times the anion concentration, and then you have the hydrogen, the entire acid down here in the denominator. So that is the theory behind this. That's our quick review of what we covered last week. Now, what happens here is what you are doing is you want to know the acid strength or the base strength of an unknown. So the first one, what we'll do is we'll have a strong acid and a strong base, and we'll be using the strong base in both cases, and that will be in the burette, and then there will be some concentration of acid down below. And what we will do is we will use, we actually have a pH meter that is involved in this one, and I will provide you the data for that. And this will give you the values here. And what you will do is you will then make a plot. It will be the pH on this one, and it will go from 0 to 14. And the volume that is added will be down on this point. The equivalence point is the mid-range between upper and lower level here. Okay, so the equivalence point for a strong acid and a strong titrated by a strong base is going to be exactly at 7. And you notice it starts off very, very low here, depending upon what that initial hydrogen ion concentration is. And it will dissociate and have a curve, that very steep change. So it's a very small range over which it is changing from this to this. That's a strong base titrating strong acid. Instead, if you go with a weak acid, titrating with a strong base, it will start off much above the level down here because it doesn't dissociate nearly as much, and it will continue on and reach an equivalent point. And instead of having that equivalence point, in other words, the midpoint between these two, right, it's going to be much higher than just pH of 7. So a titration of a weak acid with a strong base gives an equivalence point that is higher than a pH of 7. Okay? So, and what you're going to do is you're going to be making some curves that are going to be along those lines. So in this experiment, I will provide you, and you have the questions here to answer. You should be able to determine these based upon what we had before and the equations that are given there. And if you have any questions, don't hesitate to give me a call. Well, essentially, I guess, provide me with an email. But anyway, what you're doing is you're working with a burette, and then what you have is a couple of different solutions. You're filling the burette, and you're filling it fairly close to the top of it. And what you're going to do is you're going to release some of the solution in there, making certain there's no air bubbles along the wall. You do tap them gently, that you would have tapped them gently. And then allow several drops of this to drain into a waste beaker and close it off. Okay? And then what you're doing is you're reading that exact volume of the titrant in your burette and recording that as a starting volume. You'll see that later on down below here, what we have is we have a table for you to record your data right here. Okay? So your initial burette reading is going to be right here. Down below the burette, what you're going to do is you're going to be having a beaker with your unknown acid material in it. And you're going to put a pH meter in there. You could have just used an indicator, but we will use a glass rod pH meter that will give a very precise reading of the pH, much better than if you just had we're waiting for a color change. You'll see what sort of volume is added, and we'll be on. So I will be giving you this number, and and I will give you this number initially, and I will give you this reading right here. I'll give you the subsequent readings here. You can fill these in. You can and then you'll be allowed to graph those results. So imagine you're in the lab and you've got your burette filled, and it's filled with 0.500 molar NaOH. So your titrant is NaOH out right here. Your concentration is 0.500 molar right here. And your analyte is HCl. So your first reading here in your burette, you've got 45.00 milliliters. 45.00 goes right there. You've got a 0 here because you haven't added anything to the beaker down below that has your acid in it. And the pH of this is 0.301. That's your initial hydrogen concentration. It would be 0.17 molar, right? So the number that goes in here is 0.301. If you take the negative log of that, the inverse log of that, that means that the hydrogen concentration is 0.17 molar. Okay, you've added your first amount, and the reading for right here will be 35.0 milliliters, which means you've added 10 milliliters here. And the pH is now 0.77. So it's 35.0, 10 milliliters, 0.77. add 5 more milliliters. So this right here is 30.0 milliliters. And this becomes 15.0 milliliters. The pH is now 1.15. Next row, 25.0 milliliters. So that means you've added 20 milliliters total, and you get a pH of 7. Then you add 0.4 milliliters, so it's 24.8 milliliters. Sorry, 24.8 here, which means that this value is 20.2, and this is 11.3 for the pH. This drops down to 20.0, which means you've added 25.0 milliliters, and this becomes 12.91. And this one right here, your final one that we're going to be adding here, your reading is now down to 15, which means you've added a total of 30 milliliters, and this becomes 13.50. You can replay that if you need to get any of those numbers, and those will be the ones that you will record in that on your graph. Remember, this right here is your vertical axis. Your numbers that you have right here will be your milliliters of this titrant added. Let's continue on. And we will do the next titration. Here's where this curve, this right here. So along this axis right here is where you have your milliliters of sodium hydroxide that you added. This right here is your pH values. Okay. For the next one, we're going to do a weak acid. The analyte in this case is going to be acetic acid. You're going to have 10.0 milliliters of a weak acid, of acetic acid. Here you're going to titrate again with 0.10 moles of sodium hydroxide. It's 0.10 here. So your first reading here, again, we're starting off at 45.0 milliliters. So nothing has been added. Here your pH is 3.00. Next reading is 44.00. So you've added 1 milliliter, and your pH reading is now 4.05. Quite a change. This is 42.5. So you've added 2.50 milliliters, and it's now 4.50. This right here is 40.00. So that means you've added 5 milliliters. Your pH is at 5. 37.50, 7.50, and this right now is 5.48. Next one down is 36.25. This is 8.75 that's been added. This is 5.78. I'm sorry, yeah, 5.85. 5.85 there. You next go down to 35.50. This becomes 9.50 added for 6.28. We're getting close. 35.25 here. 35.25 gives you 9.75, or a total of 6.59 for the pH. The next one, 35.10 for your burette reading, 9.90 for the volume added, and you have reached 7.00 for your pH. We'll continue beyond that point. 34.90 here, 10.1 here, and that reaches 10.70. 34.75 here, 10.25 here, 11.09 here. And I'm going to stop there, and we'll continue on in the next video with the rest of the data.